actually happy.
For is Value Host. They're the ones who put up the food, and there's a banner, and there's a couple of people here from Value Host. We're an application backend hosting service as well as support. So today we have a panel discussion on operating systems, and Mr. Rick Moen will get a little bit more into that, or maybe Jesse will get into that. So for next month we have in June Mr. Jonathan Corgan from New Radio. That's going to be quite an interesting talk because it's a software radio. One of the applications of it is you can set up your own cell service. July happens to fall on the 4th of July, so we don't have a meeting. This is I think the first time I'm announcing it, so I don't expect anybody next month. In August, we have something quite interesting. The project name is YACY, Y-A-C-Y. It's a P2P open source search engine out of Frankfurt. And Mr. Michael Christian will be speaking there. And we have quite a bit of food. We're expecting many more people, but feel free to help yourself. And with that, I would invite anybody who has any announcements to come up. Anybody? No. Okay. Jesse, you're up. This is Jesse Monroe.
Thank you. I'm Jesse Monroe, and I'm just going to give you guys some quick announcements. First, thank you again to Symantec for letting us be here. Value Host for providing us sandwiches and drinks. And the next thing I want to remind everyone, please take out your cell phones at this time and put them on vibrate or turn them off, please, for the evening. And the next announcement after that is the location of the bathrooms. Have you not been here before? The bathrooms are straight that way through the double doors and straight back all the way back. That's what the bathrooms are. The drinks you can see on the table there. Thank you again, Value Host, for providing drinks. If there are any job announcements, anybody coming here? Meet in that cove back there when we're all done, if any job recruiters are here. I also want to mention quickly before handing it to Mr. Moen, BOFUG, the B Area FreeBSD user group, meets on the second Thursday of the month, and we're happy to help out with this here. They meet, thank you. We meet at the Hacker Dojo, which is up the street. Hacker Dojo is about 2 blocks away. Also want to mention the San Francisco HTML5 group is getting excellent speakers if you want to learn about HTML5. And there's a new open cloud computing center a few blocks from here in the old Veritas headquarters building, 2 blocks from Yahoo. And they're going to be doing incubator as well. We have an after dinner, which Mr. Moen has some details on that. And I want to take 2 quick polls here. First one is about Meetup. How many people would like to hear about this on Meetup? Anybody here? Meetup? Just 2? How about any announcements on Twitter? Anybody on Twitter? I've got 3. Okay, that's it. And I'm going to hand it over to Mr. Moen over there. He's the moderator tonight. And he'll take us through the rest of the evening. Thank you.
Well, we're not only a Linux user group, but we really don't care all that much. We are good friends with all of the other open source communities, and especially our Unix brethren. This is intended to be a relaxed panel where we have friendly back and forth, and I would encourage the panelists to completely ignore my questions. They're simply intended as conversation breakers, openers. You can break the conversation yourself. In lieu of, since we can't supply the Jamesons to get you talking, we'll just have to use a relaxed attitude. So we welcome everyone to the multi-OS panel discussion. Many of us are familiar with at least a few of the options represented here. In fact, some of us have run many of them, I certainly have, and would be perfectly happy to use most of them and perhaps all of them, or any of them, as my main server and desktop OS. So I'm delighted to make greater acquaintance with these fine offerings, and I hope everyone else feels the same. We have a number of distinguished panelists here. I had sent out this little blurb to the panelists and didn't hear a lot back in the way of I hate it, so I will just proceed. Dr. Kevin Dankwardt, over there, founded the training and consulting firm K Consulting in 1992. He's been ubiquitous in conferences and technical journals as a speaker and trainer on embedded Linux, Linux system and network administration, C and Perl programming, Unix system programming, Linux device drivers, and a variety of other related specialties. Dr. Dankwardt has also been Professor Dankwardt during his time teaching at Louisiana Tech University and chairing the computer science department there. Josh Paetzel got his start with FreeBSD in 1996 with a FreeBSD 2.15 install CD that he bought off Walnut Creek CD-ROM, as did many of us. Walnut Creek CD-ROM of sainted memory, as I said. He's now a source committer, a member of the release engineering team for FreeBSD, a sysadmin for the PCBSD project, and project manager and developer on the related FreeNAS project, something I've looked into for running for myself. Describes himself as a sysadmin who can do some programming, which is something I can very much relate to. Dr. Charles Forsyth has a very formidable background as a systems software specialist, having picked up an interest in Unix in its very early days when it had barely escaped from Bell Labs, and has worked in software engineering with Unix systems at almost every level over a long career, working on protocol stacks, compilers, kernel subsystems, shells, commands, libraries, a data storage subsystem, code generator, and on and on. In 2000, he founded Vita Nuova Holdings Limited of York, thus appealing to all of us fans of Italian literature, to develop and promote the Inferno and Plan 9 distributed systems for embedded systems and network devices that Bell Labs produced. Bryan Cantrill is VP of Engineering at Joyent, and cut his teeth as a software engineer during summer vacations working on the QNX microkernel, and then joined Sun Microsystems working in the Solaris Performance Group. I believe he's one of a small group of engineers we have to thank for dtrace, and then in 2008 co-created a stealth project within Sun called Fishworks to leverage Sun's new technologies to take on the NAS market, which came to market with the Sun Storage 700 series of NAS appliances. In 2010, following the Oracle acquisition, he left Sun to join Joyent. Let me blather on for just a moment before we get into the questions proper. It's delightful to have such a wealth of healthy and useful open source Unixes. SVLUG has always made a particular point of extending friendship to our brethren Unixes, and so we've invited representatives from leading Unix derivatives to talk with us and broaden our horizons. I've personally experimented with many, not all, of the projects we've invited, and I hope to learn more. How am I doing? Okay so far? From each of our panelists, I hope that you could tell us each a few words about your project's histories, particular strengths, and most compelling uses. And whoever wants to go first, feel free.
Okay, we can start this side. So I think everybody knows a good bit of the history of Linux for 20 years. Old now and ubiquitous across a lot of spectrums of computing. I think that's one thing that sets Linux apart from any other operating system. It's great range from really fairly small devices all the way up to dominating non-tech-specific computer market.
Okay, I was actually amazingly brief. I was given the question. I was going to be amazed about anyone else. Just because
Run with it if you want.
Alrighty, you can easily, just on the history of these systems alone, each of these systems, you can obviously expand on I represent Illumos and Joyent's Illumos through SmartOS. Illumos has inherited the mantle from OpenSolaris, which of course comes from Solaris, which comes from Sonos, which comes from System 5, which comes from System 3, which comes from actual honest-to-God Unix. Not that everyone else is an honest-to-God Unix as well, but there actually are bits in the source base that date from 1973, which is pretty amazing. In terms of why Illumos, I think that, and just something I would emphasize, by the way, for all of the panel, and I think all panelists would agree, that we have much more in common than we have that separates us. And we in the room, and more broadly, we have a certain ethos about the way a system should be built, and that ethos is reflected in Unix. And I think that we've got different expressions of that, but there are many more commonalities than there are differences. And yes, you will find specific technologies in one system or another, but the beauty of this kind of open source era is that a system does not hold those technologies captive. In terms of our system, we have particular technologies like dtrace, which is a facility that allows you to dynamically instrument the system, CFS, which is a next generation file system that we can discuss at length. We've got zones, which allows for OS-based virtualization. We have KVM, which is unlocks the microprocessor for hardware-based virtualization. All four of those technologies are present in one form or another in these other systems. None of those technologies, yes, dtrace and CFS were born in Solaris, but they exist in FreeNAS and they exist in FreeBSD. KVM was born on Linux, and we ported it to Illumos. Zones is a Solaris-born technology, but directly inspired by jails on FreeBSD. So I think that when you look at these OSs, don't look at them as silos. Look at them as particular collections of technologies, but really zoom in on the technologies. It's the technologies that are much more interesting, and the technologies cut across the systems. With that, I hand it off to Bryan.
Well, actually, it's just that you go next.
Oh, sure. So FreeBSD has its roots back to BSD Unix, which comes from Berkeley, which is in this area. It was mainly funded as a research project into networking by the government, and so that they use Unix as a system with a lot of enthusiasm. It was small at the time compared to the other systems. People knew about it, they could learn about it, and so it was funded by the university, by the government, and gained a lot of momentum in that area. BSD became known for networking since TCP originated there, and FreeBSD, after Berkeley finished with their research project, FreeBSD was born with NetBSD to take that code base into the 90s. You'd find that the early strengths of FreeBSD were its networking stack. It was fairly unrivaled in the open source world. As the rest of the open source world caught up, FreeBSD started to show its age. Fast forward to today, we've had ZFS for about 5 years now, and FreeBSD has sort of gained a new life and a new relevance due to that file system. It's mainly used, and I run a lot of FreeBSD servers, but it's mainly used as a platform. These days it's used in all sorts of commercial appliances. It's behind the scenes in all sorts of devices, and I dare say that its primary user base are the people that build systems on top of FreeBSD these days.
Okay, well, I feel a little bit as if I've sort of fallen into an alternative universe, or fallen in from an alternative universe in a way, because the systems that I sort of represent are unusual in this current set, because they are not based on Unix at all. And all the code is different, of course, but the ideas in Unix will be built for planline and then adapted again in a slightly different environment for Inferno. So the two systems were planline, which was the first system that the labs at Bell Labs that developed Unix went on to do after they'd given up on Unix. They felt that in the new networked, or then new networked and distributed world, that there were fundamental problems with Unix that had been built into Unix that needed to be dealt with, and that couldn't be done by simply adapting the existing system. And so they set off to do a completely new system. It's starting from scratch, so all the code is new. Somewhat later, the ideas were adapted. So Plan 9 looks very much like a normal native kernel running on a machine. You can use it in an embedded environment, you can run it in a big system. It does graphics. It supports networking. But it's intended to be used to build distributed systems. Now, that doesn't mean the sort of systems that Google builds, big, large-scale systems, but rather more in the line of the Cambridge distributed system, or some of the distributed systems that were being developed at Xerox PARC some years ago. So there are that is to say, you build a large computing environment by putting together a number of specialized components. And the system provides both a structure and a mechanism to allow you to do that. The structure is that all resources in the system are accessed through what's known as a namespace, which looks like a directory tree. But the things in it connect typically not usually to storage files, but rather to services that lie behind the names. The namespace is also per process, so there isn't a global namespace or one for an entire machine. Instead, a process or a group of processes builds a namespace, assembles a namespace to suit whatever it is they're going to do. That also acts as a kind of installation. In other words, because all system services are accessed to the namespace, if something is not in the namespace, you can't access it. So it provides instantly a way of isolating processes and restricting access to services, or enabling access to services by putting into the namespace. The mechanism is a single file service protocol that's used, called 9P, that's used to assemble the system, and that's how an application level, a user mode program, can provide a file service, is that it implements this 9P protocol. Having done those two things, providing all resources as files in a computable namespace, that's the one you can assemble, and providing a file service protocol, distribution becomes a matter of simply connecting over a network to something that serves the 9P protocol and putting it into your namespace at any convenient or conventional point. And so the advantages of the system are that you can very easily put together out of a collection of pieces and reassemble, restructure things very straightforwardly, obtaining location independence for these things' names. And even within the system, services like DNS, network connections, there aren't any socket calls, for example. Instead, you access the network by opening a name that's typically bound in a conventional place like /net/TCP. You open a thing that looks like a file, and you write to it a text string, so there are no IO control calls and no binary socket calls. You write a text string that says connect, and then a textual form of an address you want to connect to. One advantage of that approach is that immediately you get a kind of protocol independence, because instead of having to say, well, this is an X25 socket, this thing takes IP addresses, a character string can represent can have a textual form of any kind of address. Then finally, Inferno is a later system. So Plan 9 was first released in the early 90s. It was made open source around about 2000. The Inferno project began at the labs with the aim of producing a system for set-top boxes, and that started to run. That went into sort of made available for customers to use in about 95, 96, which is when we got interested in it, or my company got interested in it, and was formed to take advantage of it. Subsequently, in about 1999, there was an attempt made to spin out the Inferno technology into a commercial organization to look after it, and the first attempt, from our point of view, fortunately failed, and we were then able to acquire the software, and we've owned and developed it further ever since. The one difference between Plan 9 and Inferno is that Inferno has a mode called hosted mode, so that it runs under operating systems like Mac OS, Linux, Solaris, FreeBSD, and to those systems, the operating system looks like an application, but to its own applications, it looks like the same operating system as when it's running native in an embedded box. And so you get much more flexibility about assembling systems. It also means that it can virtualize resources of the host system so that I can routinely, for example, import network interfaces from a remote Linux system that's running on a virtual server somewhere in New York, and make use of those to make outgoing calls from a computer system that's in my loft. Why would I want to do that? Well, because there's this horrible thing called the RVL list, and it turns out that my loft address is on that list, so I can't send email. But I can import a gateway from this commercial service running Inferno on top of Linux, and thus make its network interfaces appear as though to the applications running in my loft, appear as though they're directly available to them when they open up network interfaces to make SMTP calls. The packets, it's not like that. The packets don't appear to come from that address. They really do come from the remote gateway through the Linux system. So I think that's probably given a little bit. Okay, so I should say one more thing, which is that the only things that the system kept from Unix are the principles of having open, read and write, and close to access files, and the idea of forking to create new processes. But there are special versions of fork that can create new namespaces, that can copy or share namespaces, that can share memory in processes. So there's a strong emphasis on programming, support for SMPs, support for Nuova in more recent developments, and so on.
I would assume that it shares the notion that everything's a file.
Well, it takes it to its extreme. For example, there are no major and minor device numbers because when the kernel boots up, the kernel drivers present a set of names, and those are the names representing the devices. They don't have to be stored somewhere in a file store because the kernel knows which devices it's got available and simply generates the names to give access to the devices.
Dr. Forsyth, where would we tend to find major deployments of Inferno in the commercial world these days? Since I'm sure we're all curious, and it's perhaps the least familiar of.
It is, but and it's I would say it's essentially a research system. I think the same is true. It is not. It is a little inaccurate because it is being used. We use it, for example, to build things like a grid system, a computational grid system, where the resources, the scheduler in the grid system presents names, and then the client worker machines mount the scheduler's namespace, and the way they do is they publish subscribe to get work. As they open a file and read it, it blocks until something's there to be done, and then they carry on. So we use that to build systems that we then sell to pharmaceutical companies, actually. And Plan 9 has a wider use in embedded field. Excuse me. I gather you've already had some talks from people at Corade, and they make extensive use of it inside to make the construction of their storage subsystems easier for them. I don't know how much of the Plan 9 capabilities are exposed to the end user. But I think Corade probably is one of the bigger commercial deployments, certainly in terms of numbers, of Plan 9. And there are quite a few others. Inferno, it's harder to say. One of the difficulties, maybe this is perhaps more generally true of open source stuff, one of the difficulties with open source is that because anyone can go across to Google Code and pick up a copy, there's no particular reason for them ever to have to deal with us. Right. So it's only when they ask questions on news groups or mailing lists that we begin to see that people are doing things. So there are some Russians that are doing something with Inferno, but I do not know what it means.
We all learned this effect back in, I believe it was 1998, when everyone was busy denying that they were using open source anywhere, and then first the Mozilla announcement came out, and then all of the SQL databases pretty much fell over each other announcing that they were shipping for first Linux and then the BSDs in many cases, after denying that they had any such plans for years. So there tends to be this effect of the code being subterranean, as it were, not really well known to the public. And that's actually part of the purpose of this panel, to help publicize some of these technologies. you all. One of the major trends in Unix over the last few years is the emergence of large storage with corresponding management challenges, integrity and scaling issues, and in some cases the threat of week-long FSCK times. Solaris seems to have set the standard with the ZFS file system, permitting such winning features as deduping and the detachable ZFS intent logs. You can have that on a separate device. BSDs and Apple are able to use ZFS mainline code natively on account of license conflict. CDDL and GPLv2 don't ask. Linux users' ZFS options are limited to a user space, fuse implementation, and a rather odd kernel space patch set available only in source code, as distributing it compiled would be unlawful. Or Linux users can just deploy Nexenta OS, which approximates, I would call, a slightly eccentric Debian running on a Solaris kernel. I would appreciate the panelists speaking about their OS's roles if they have them in modern storage deployment. I'm sure some of you can run with that. As always, feel free to interpret my question any way you want and run with it as you please.
Which one do you want to start?
Go ahead, Joyent.
It's a very tough question, but it's a fair question. Yeah, I mean, I know obviously the ZFS is, I think, reflects the kind of the new reality you described. And to be fair, and Jeff Bonwick, the creator of ZFS, saw those problems over a decade ago, and we saw spindles were getting larger, spindles were getting more plentiful. That we had developed, we developed RAID in the 80s, and we, in order to make existing file systems work with many spindles, we had invented this little layer of software that actually built the building we happen to be in, called volume management. And volume management took many different spindles and presented them as one logical spindle. And that was terrific because it allowed existing file systems to work. But as often happens in the case of software, it was a great short-term decision, but a poor long-term decision. And we realized that we actually needed to blow up the whole thing and re-architect storage whereby a file system understood the notion of multiple spindles, because UFS never did. And so we did that originally in Solaris, and fortunately that was open sourced along with the rest of the kernel, and it's been very gratifying to see that show up in so many other systems. I think that ZFS is really, and I think that it bears re-emphasis. If you look at an enterprise-grade file system, there are really only a very small handful. And by enterprise-grade file system, I mean a file system that has walked the trail of tears. And the trail of tears is dealing with all of the pathologies that you have in a storage subsystem. Disks are not gentlemanly. They do not fail in a gentlemanly manner. It would be gentlemanly just to blow their brains out when they're feeling, but they don't do this. They act pathologically, they act in a manner that is frankly Byzantine. Writes are thrown away, writes that you never asked for suddenly appear, reads come from the wrong sector, disks reboot. We had a firmware bug where the disk was misapplying the voltage on the head. It was trying to accelerate the head when it was supposed to be decelerating the head, which would have crashed into the spindle and the cylinder and literally left a crater. Some piece of the spindle realized this and actually simply brought VCC to ground and actually rebooted the spindle. Which you only see because you see this strange 800 millisecond outlier in your I/O. That could be your spindle rebooting. And so because with all of these methodologies, it is very, very difficult to take a body of software and make it tolerant of all these kind of failures. And historically, the only bodies of software that did that were strictly proprietary. They were NetApp and Waffle and ONTAP, EMC certainly, with both. I mean, EMC's got both the Clarion line that they inherited from Data General and Symmetrics. Then you've got Repar, I guess, and now you're down to what? Isilon, EqualLogic. I mean, the number of enterprise storage players is actually quite limited. And then you have ZFS. And ZFS, which is running on quite literally millions of enterprise-grade spindles not mom's laptop, where mom doesn't understand when she has data corruption, but enterprise-grade spindles, and it is the only one of those that's open source. And from our perspective, not just the technologists who were there and implemented it, but anyone who's deploying anything in a serious manner with respect to storage should be on ZFS. And I think others have come to the same conclusion. And I mean, it's part of the reason why you've seen it in FreeNAS, why you saw the effort from Apple, and why you see it in so many different systems. And I would say, I think part of the reason also that you have seen it in Linux as well. And I just want to clarify your comment. You said it would be illegal to ship it. I think that there is a perception issue that I think we need to tackle. One point that I would like to make, because I think I said earlier that I think we've got much more in common than we have that separates us. One of the most important things we all have in common is we are all open source systems, and we need to end this self-inflicted madness of open source licensing compatibility. I think that it is a boogeyman, and we are letting it hold us back. I mean, you say it would be illegal to ship. I say no one has standing. That the GPL was never ever designed to counteract other open source licenses. That's not what that is, a complete rewrite of history to believe that the GPL was designed to be at war with BSD or with Cuddle. The GPL was at war with proprietary software, and thank the GPL and Stallman, open source won. That's the whole point. Open source won, and we are pissing on our own victory parade by not allowing these technologies to flow between systems. So we certainly, we in the Illumos community, and I think in the BSD community as well, I think you see an ardent belief that when it comes to open source, let's take the best of breed, and we all should. So I would say on that note, ZFS, don't think of ZFS as an Illumos technology. Yes, Illumos is the repo of record for ZFS. We work a ton with the FreeBSD guys, but ZFS is a technology that's open source, and it should be in every open source system out there.
Okay. So if we're talking about file systems, and I relate that to Linux, I need to say that Linux has lots and lots of file systems. And the enterprise is just one sector. So Linux certainly has been very successful in the enterprise. Very large systems, lots and lots of spindles. I mean, Google uses ext4, which is really the most popular enterprise file system for Linux. But Linux needs to deal with a lot of devices, not just enterprise disks. Your cell phone doesn't have a traditional disk in it, right? So there's a lot of file systems at the embedded end. There's different network file systems. And in fact, in the last several years, this idea that Unix typically had of everything as a file has really developed in Linux to be a really popular notion. So there's just more and more stuff in Linux that appears as a file. And I think a lot of people here are probably Linux people, right? So you're familiar with the proc file system and the sys file system, and now there's the debug file system and the relay file system. In fact, more and more interactions with the kernel are through a file system paradigm. This idea of a device file matching up a major number with a driver and a minor number, typically which instance of a device, is fading away. Linux now is pushing the notion that device files are created dynamically, and the numbers don't matter that much. So it's maybe a little more similar to what was talked about before, about the relationship between a name and a namespace and a device is a little less than it used to be in traditional Unix. Also, certainly something that sets Linux apart from any other operating system is the pace of development is so fast. And file systems have been very popular, so there's been a tremendous amount of effort and continues in the Linux world in developing new file systems. One kind of interesting point some of you might be aware of, there was a fairly innovative file system that was the first journaling file system from Linux world, we called it Journal. And the inventor of that was literally a crazy guy who's now in San Quentin. But that idea of a journaling file system to avoid a potentially week-long file system check, was realized, and certainly in the Linux world, people couldn't put up with that. So that problem's been solved pretty well. Now, one thing that was mentioned about ZFS is data deduplication. Now, I'm not a file system guy, so I don't know the details there, but that's an interesting point, and I've just kind of peripherally heard that that's something that's apparently has some solution or some effort going on in Linux. I've also heard repeatedly that ZFS is kind of drooled over that. They've definitely got some features that Linux folks wish they had. And I think there's a lot of diligent work probably to try to include in newer file systems like ButterFS is apparently one that a lot of people are excited about. And perhaps that includes, I don't know if anybody here can speak to that, features of ZFS that have been hoped for.
So ZFS was a game changer for FreeBSD. It brought a new generation of file system technology to an operating system that historically has fairly old technology in it. It is a copy on write file system, so it brings a lot of things to the table that a copy on write file system has by nature, and so it's very similar to Waffle in NetApp. And in fact, NetApp and Sun went to the court about that because they're so similar. And a lot of the properties and characteristics of ZFS are directly derived from the fact that the technology that's used to build it, snapshots, are really cheap in it. To a FreeBSD guy, that's like an epiphany, right? A snapshot that doesn't take 7 hours to take and doesn't have the potential to crash my system, what are you talking about, right? But once you get used to using them and having them around, it's kind of like, I liken it to cell phone technology. I grew up in an era when cell phones were not prevalent. And now I wonder, like, how did they even do anything? They're so useful, how did we all get together on Friday night, and everybody got there, and it changed the game. Having a cell phone and instant communication changed the game, and ZFS changes the game. Once you use snapshots, once you use clones, once you use some of its features, you can't go back. You just go, I just changed my source tree, I took a snapshot real quick, it didn't work out, and I reverted my stack, and that was instantaneous as opposed to trying to roll back this patch or whatever you're trying to do. And in terms of licensing, I agree. It's a shame that licenses cause the sorts of duplication of effort that open source was invented around preventing. So for instance, you have the whole ButterFS file system wouldn't even exist if Linux had ZFS. In reality, Clang wouldn't exist if GCC could be used everywhere. There's tons of people working on things that are just, yeah, we've already done that. We already have GCC 4.6 now or something, and yet we're working on getting a different compiler working on architectures that GCC had figured out a decade ago. In terms of file systems, ZFS is, I deal with it every day, and it shows that it's only 6 or 7 years old now. More mature file systems like XFS that have been around a long time don't have the sorts of problems that ZFS has. And those are just teething problems of, in the file system world, 6 years is pretty new. And you look at the ButterFS guys and go, wow, you guys are 3 years behind that. And it's just, what a waste. Why do we have to have these competing projects? And it's all because of butting heads over licensing. And of course, coming from the BSD camp, one of the strengths of BSD is its license. You talk about being hard to quantify where your operating system is used. FreeBSD actually has that problem as well, in that its primary user base is as a platform to build things. And oftentimes, the first time the FreeBSD community knows that it's being used somewhere is someone will post looking for a kernel developer to a mailing list, or someone will notice, I think very recently, some FreeBSD guy, just some random guy who's using it, his TV, he was doing a firmware update and the kernel panicked, and he saw FreeBSD copyright and the kernel panicked. And all of a sudden they go, wow, Panasonic TVs are running FreeBSD. Nobody knew. Like, nobody had any clue, you know. And recently Netflix, a few months ago, posted a job posting to a FreeBSD mailing list looking for a kernel developer. And what? Netflix uses FreeBSD? And then, oh yeah. We need a kernel developer, right? Nobody knew. And so that's a problem as well. There's just no meta information on that. People like the license. Companies like the license, you know, it allows them to do their own thing. And yet, at the same time, that license prevents use of other technologies. For instance, the very reason why Clang exists is because people said, no, we don't want GCC or GPL version 3 code in our products. And they said, no, to GCC 4.3. And so they had to do something. You know, processors move on, architectures move on. They couldn't stick with a static compiler that wasn't going to change. And so they started writing Clang. And you look at years, man-years of effort, you know, gone to waste, essentially. Those problems have already been solved, and yet a few words in a license stop us from using it. So, in terms, yeah, go ahead.
I was going to mention that in a previous life, I did systems programming on Burroughs 6700 mainframes. And one of the things that I found very attractive, although a very minor point admittedly, was that IPC was treated in the compiled languages as a file. And at that point, IPC was usually very complicated to everybody else. But I thought it was such an obvious thing that when you want to talk to another program, you open a file with a name that it shakes hands with and you're talking. And it also had one-to-many and that sort of thing, although it didn't get into it. But I thought that was an excellent thing. And when you would talk about everything's a file, especially for IPC, that's what it came up to me for.
Just a brief observation or two. Back when I worked at VA Research and VA Linux Systems around a decade plus ago, I got to know some of the file system guys there who were very careful about immature file system code, which of course had been a problem and continues to be. They also praised XFS for its quality, but observed that even XFS is primarily written for quality hardware that tends to lose power in a deterministic manner and shut down without misbehaving. So you have the problem that it's not defensively written to use against rubbish hardware. The way, Ted Cho said that the code for ext3 and so on was specifically written to compensate for rubbish hardware, which was a very good thing and has saved a lot of people's data. We also had a joke around VA that fsck.riser really was functionally symlinked to mkfs.riser. We're scouting out the file system people out there.
I suppose I should say a few things about
Of course.
file servers and Plan9. In the talks I give about Plan9, or introductory talks I give about Plan9, I usually have a thing that explains the namespace and file servers and what a file server is, and I explain that these file servers mostly don't do boring things like store data on disks, they provide services. But Plan9 did have, I mentioned earlier that it had a structure inspired perhaps by the Cambridge distributed system, and so the way that you built a Plan9 system as a whole was as a collection of specialized parts, so that from the earliest days, the Plan9 had a file server as a standalone kernel that ran only file servers. In fact, it ran it in kernel mode only. It was a kernel mode program, a small kernel, sort of embedded style internally. And all it did was serve files over this protocol 9P, or the earliest version of the 9P protocol. And all other all other users of the file server would connect to that over the network. So there wasn't any local storage. Instead, there was a collection of file servers, terminals, which were the things that had graphics display, and multiprocessor, big multiprocessor CPU servers. In fact, FastServer also ran, FastServer kernel also ran on a big multiprocessor.
Able to ship source. Sometimes it's contract requirements where they've sub-licensed technology and they're not allowed to open source. There's interesting things like if you're doing a cell phone and you're doing a driver that controls the radio, the FCC restricts power levels and frequencies and so forth. And if you open source your driver and your device was out of compliance, are you liable for that? So there's some interesting intricacies in being able to open source stuff. So I personally, I give companies a little bit of latitude when they don't open source stuff. But when they do, there's certainly a lot of advantages to that and folks fixing stuff. Now, the gentleman back here said something that I wanted to kind of mention too, that there's kind of a saying in the open source world that nobody has to reinvent the wheel, that everybody benefits when someone solves the problem. And the GPL doesn't require that. In fact, it's fairly common practice that folks do not release stuff back. The GPL doesn't require giving back, technically. It requires what I call giving forward. So original authors of code oftentimes don't get fixes for their code, even though fixes exist. And in fact, multiple fixes. And at any given time, there may well be lots of versions of drivers that independent companies have fixed, and they don't feel motivated for whatever reason to contribute that back. So it is a bit of a problem, but in practice, in kind of reality, things do work pretty well. There's tangible benefits in contributing back, and you don't have to continue to support it yourself and whatnot. So for non-altruistic reasons, but for real business, practical reasons, folks do find value in giving back, and that continues. And more and more folks are convinced of that. So I think that's proven to be pretty effective.
I think for us, we're mainly on the server side. There's slightly less mayhem on the server side. You don't have, laptops are murder to support because and I think that this is even with Linux, you look at its ubiquity, and it still struggles on the laptop because of Wi-Fi, because of all the devices and so on. And I think it's hard to do it, to not do it the way either Windows or Apple have done it. That is to say, you run on everything, or you run on only your thing. On the server side, things are a little better, or maybe even a lot better. It kind of depends on the particular component you're looking at. NICs, for example, are pretty straightforward, and in part because NIC vendors, Intel doesn't actually want to have a from-scratch driver rewrite with every new NIC. It's not in their interest either. So NICs are straightforward. HPAs less so, because you've got vendors that actually want to put a bunch of proprietary glop into their RAID controllers, what have you. I think that historically the challenge has been not being able to get the source code. This is where I think we, in all these open source systems, really need to work together, and I think that we have and do. And we are able to, when a vendor, thanks to the position that Linux has, a vendor has released a driver that's open source, even though our driver models are completely different, we in other OS communities can take a look at that driver, and even if we can get ported across, great. If we can't get it ported, we can at least understand what the device interface is. So I think that open source has been tremendous here, and has been tremendously valuable. I think we still need to put pressure on vendors. I think that we've got a very peculiar problem in Illumos that we're going to get over this hump, but we're dealing with. We're unprecedented in that we are a source base that leapt the chasm from proprietary to open. Unlike BSD, unlike Linux, our heritage is actually proprietary. We leapt that chasm, really being the first OS the really mainstream OS to do that. And then in just a crazy leap, a crazy twist of fate, Solaris became anyway, the first operating system, then leaped back. The Solaris went from being open to now being proprietary again. So I guess two firsts there. We've got a very, very strange phenomenon that you have when they open source the operating system, a bunch of device vendors were very excited about that development and contributed their drivers into the operating system that has now been made proprietary again. So we do have this kind of strange problem that we've got particular vendors like Broadcom, LSI, others, that we're having to go back and kind of reestablish covenants with. It's a challenge, it's an organizational challenge. I think that the way to do it is that we work together. We work together as a community across our technologies, and we go make the vendor, or help the vendor do what we need the vendor to do. One other thing I would say about that peculiar bit that we have, at least in ZFS, ZFS was really designed around, instead of having incredibly intelligent hardware that you were relying upon to always get it right, ZFS made the realization that actually, no matter how much you pay for your hardware, it's not going to get it right. You actually want to have cheap, stupid hardware, and you want to have smart software. ZFS built the smart software. We're actually having a hard time getting the stupid hardware. It is actually hard to find HBAs that pass through. Every HBA insists on having their own little proprietary co-op in there. No, I want to be a RAID controller. It's like, no, I really don't want you to be a RAID controller. Just give me all the spindles, please. So that's a challenge that we have as well. I think it's a challenge that we are surmounting. So I think the progress is being made, and I think that there's a myth out there that for all of these operating systems, that, oh, well, you can't possibly, you're different from these other systems, you can't possibly survive because of the devices. Well, the fact that we're all open source is what allows us to survive. The fact that we can all actually borrow from one another is what allows us to survive. So that really is kind of the key difference now from a decade and a half ago.
I know that since early days there have been certain of the common drivers like the Adaptec AIC7XXX that had always been permissively licensed, so that there was not this nonsense of having to have separate trees for different OSs. It was always maintained as a common project.
Well, everything everyone has said is probably true. It would be nice if hardware manufacturers produced the sort of books that they used to produce. Even for processors these days, especially in the embedded space, with ARM and so on, there often are lots of bits that you have to work at to get information about. I think Rob Pike said once that there isn't a principles of operation for a lot of this stuff. Referring to the System 360 370 series documentation, which was very detailed. And then actually, that's true of quite a bit of the documentation of mainframes and computers in the past. Because they expected people to want to write software for it at a low level. And it's true that there often are Linux drivers that you can use to get some information about how to drive a device. And we do that. I would say, though, that having worked on a driver where I've had the Linux drive to hand and also some what I call proper documentation for the hardware, it's much, much easier and the driver is much better working from the hardware documentation, because the model that you have, how you want to drive the device, is often quite different. Or else the driver just does things and you can't work out whether this is absolutely essential, or whether they've misunderstood something, or whether they had a buggy version of it, which is not unusual, and therefore had to do something you don't seem to have to do. It would be much, much better if people just document the hardware.
Your comments, and then we'll have to wrap up pretty quickly after that.
So we had a group of Intel engineers at the shop a couple months ago, and they were watching us assemble servers. And we showed them we're mostly an Intel shop at this point in the game, and we walked them down the lines where the guys were putting processors into servers, and they said, well, that doesn't look like an Intel motherboard. Well, it's not. This particular system is getting a super micro motherboard, and the engineer goes, "You can do that?" And we were like, "What do you mean?" He's like, "You could put an Intel processor in a super micro motherboard?" I thought they only worked in Intel motherboards, and very brilliant person, very, very brilliant person.
So you're saying it's just as well they don't document the hardware?
When you talk to this guy, he could make your brain explode about some little part of a subsystem of a modern processor that he worked on, and knew far more about it than anybody at our shop, for certain. And I think what that reflects is that modern hardware is getting really, really complicated. And the ability, if Intel says, hey, we're gonna give you a preview of what we're working on. Here's our next generation hardware platform, and you get to see it first. This will be out in about 6 months. Here you go. The reality is to get an operating system into shape to use that takes longer than 6 months at this point. You know, it's not a basement project for Jim and Steve to go home and work every night and, you know, after work and go make this hardware go. And without specs at a certain level, you know, the latest Westmere processor has hundreds of millions of transistors in it, and the spec book is, you know, thousands of pages long, and great, you have the specs, good luck, have fun, you know. You really need a driver team at Intel helping you with your operating system. We were working on a RAID controller driver for a new LSI Thunderbolt RAID controllers that are new as of a year ago. And you know, we started, hey, let's get some hardware specifications, let's get some hardware docs and stuff like that. And talking to LSI, they go, actually, those docs don't exist. We haven't had time to update it, right? You know, we have our engineering team that's worked on it, and they know a lot about it, but the documentation you're looking for, we simply don't have. You need to talk to these 6 guys if you have questions.
I sent LSI an email asking for the documentation for that part this afternoon.
Yeah.
So
Good luck.
thank you.
With
Actually, you just saved me an enormous amount of time.
Yeah.
And actually, it's not that they won't give it to us; it's that they actually don't.
They don't have it.
That's quite
SVLUG at your
Thank you.
service.
that's quite
It's
complicated.
clarifying.
Yeah. So in reality, you know, open source projects need teams working inside these hardware vendors to provide drivers. And so you'll find that Intel drivers, for NICs, for instance, they have a FreeBSD team that works on the driver. They have a Linux team that works on the driver. NVIDIA has an entire room full of people that work on the Linux driver for the NVIDIA cards. You know, Chelsea has a room full of Linux guys, a room full of FreeBSD guys, you know, a room full of Solaris guys, you know, working on these drivers. You need that sort of commercial support because at the end of the day, you get, you know, 16 pieces of technology from 8 different people that are all going to be released new, and you're behind the 8 ball, and then it comes out. 3 months later, you support it, and 3 months after that is end of life.
Yep.
And they're on to the next one, you know? And you're going, but I haven't even qualified my new product on it, and you guys aren't even making it anymore, you know? And now I'm paying more for the old stuff because it's EOL, you know?
Oh, yeah.
And so without commercial support, open source is really a tough place. You know, the IBM PC, the XT, you could read the hardware manual for it in a couple of days. You know, these days you could take 2 years and you couldn't read the hardware manual on a Westmere processor. You just couldn't do it. So you need commercial support. And I think that hardware companies are starting to realize that, you know, open source isn't a niche anymore. It used to be if it wasn't a Windows box, it was by definition niche hardware. And I think you're starting to find now that that niche is a significant percentage of the market.
We're now pretty much up against our time limit. Time has passed quickly and wonderfully. Thank you all. We have, perhaps, we can steal a few minutes for some concluding remarks. I had in mind previously to ask you folks where you thought your systems are likely to be in 5 years and where you'd like them to be in 5 years. It's not necessarily the same thing. But any other concluding remarks you folks feel like maybe would be most welcome?
I'll say something quick. Linux's pace of development has accelerated over its whole lifetime, I think, and I think that will probably continue. I don't have a vision for where it's going to be in 5 years, but I feel pretty confident that it will continue to be successful.
Yeah, so I think that that for us, I mean, you'd have to talk about particular technologies, about where we're taking dtrace, where we're taking zones, where we're taking CFS, where we're taking all of these technologies. And I think we've got you know, ideas for all of those technologies. None of those technologies is done, and we are, in particular, you know, cloud computing changes everything. It changes everything in a very exciting way. One thing we didn't talk about at all tonight that I just want to touch on very quickly is virtualization. And you know, we've had this this tremendous revolution in the last couple of years with virtualization, and in particular, VMware showed Intel and AMD that a market existed that they did not know existed, which is for virtual x86s. It's hard to remember, but when VMware started, it was reasonable people thought you could not virtualize the x86 architecture. In what is almost a tragedy, They invented the space, and then of course Intel and AMD put in the microprocessor support that obviates all the technology that VMware had built. So VMware's in a bit of a bind that is very kind of unfortunate. But for the rest of us, and for KVM in particular, this is terrific. So we've got now in the microprocessor unbelievable support from Nehalem and later CPUs, and Standing Bridge, Western Ivy Bridge, so on. Unbelievable support for virtualization. And that's why we ported KVM to Illumos, allowing it so you can really view your OS as an application platform. Your OS in the KVM model, your operating system is really just a process. And it looks and feels and smells like its own hardware, but it's virtual hardware. So and we think that we're already seeing some cloud computing, but certainly we think that virtualization's got a tremendous future to it, and it actually unlocks us, because if your application is bound to a particular operating system, be it Windows, Linux, what have you, you can now run that in a virtualized image and now make a different choice on your hypervisor. So in terms of Illumos, we actually view ourselves as a superior hypervisor. And all the technologies that we're developing are really around being a multi-tenant operating system and a hypervisor.
Yes, so there's several groups that have plans for the future, because well, as you alluded to cloud computing, there are a number of things that have changed radically since Plan 9 and Inferno were both first developed. And I think there's several groups that, including me, that are thinking again about how to change things for a rather different future.
I think that I've seen BSD lose its impact in networking and gain impact in storage. And I think that you're going to see, BSD is behind a lot of storage right now. I think you're going to see that to continue to increase, and I think you'll continue to not see it behind the scenes in the embedded field. It's the operating system you've never heard of that you used every day, and that's going to continue to grow.
Thank you all, and thank you everyone. We usually have an after-dinner gathering, and it's traditional to not let our guests pay if they want to join us for dinner. That's over at Frankie, John, and Luigi's 2 restaurant, Italian restaurant, on El Camino Real. It's between Castro and Shoreline on the far side of El Camino Real. So there's typically a set of cars and other vehicles on the way to the restaurant. If people can indicate whether they want to attend, we can let the restaurant know how many we're mobbing them with. Show of hands. Thank you, everyone.
And one more thing, we have a bunch of sandwiches which are still there. So if anybody wants to take sandwiches, please take them.
Around the 2005, 2006
Various interesting bits.
FreeBSD probably has the most mature
Sure.
any of the BSD projects out
Comment
there.
what way.
Well, I mean, just use both camera views to generate one sort of
Grab my,
all of the screens.
I was gonna have time.
Is that where the slides are?
Yeah, at the end, we'll give it to you right now. That's where the slides are at.
No.
So that's the last slide. I'm gonna go back to the beginning. And when John's ready, we'll get started.
I should be able to take a picture of that keypad.
Yeah, it should be able to.
All right, I got it.
You got it?
Yeah.
Okay, I'm not gonna use the microphone. This is only 4 or 5 of us. Tony will be here in a minute, but, we'll just get started here. All right, well, thanks everybody for coming, and
You want to go ahead and start early? And if we, and then even if we
Yeah,
do,
excuse
we'll
me.
let Ali talk to this
Ali,
huge
why don't
crowd.
you start up?
Yes. Can you hear me? I just wanted to say, you know the drill. Hi guys, cell phones, please silence your cell phones. Next month we're having Gabriel done, and the talk topic will be processing.